Okay, here we are. It's Friday afternoon, 3 to 4 block with, make that the 2 to 3 block with Hawaii, the state of clean energy. We're talking about storage at the center with Bill Capp, who's a consultant in storage, calls his company Grid Storage. Welcome to the show, Bill.
Thank you, Jay. Good to be here.
Great to have you here. So I guess the first thing is just to qualify you as a witness, so to speak. I used to be a lawyer.
I've heard that.
So how'd you get
a
into
recovering lawyer?
Exactly.
Yeah.
It'd take me the rest of my life to do it. How did you get into this business?
Well, in my prior life, I was CEO of a company called Beacon Power Corporation, which is was a small publicly traded company, and its business was energy storage using high-speed flywheels. And it had a public offering in 2000, and about a year later, the board of directors realized that the business model wasn't working. And so through a network contact, they reached out to me and they said, would you like to have a look at this? And I quickly realized that it was great technology and a fabulous organization and some money left over from the IPO, but the business model wasn't going to attract any more capital or make any money. And so I came in just with a belief that there was something there. And so we spent a year figuring out what to do, and that led to the idea of using energy storage to support the grid, which that hadn't happened before, other than very small cases. But on the mainland, there are organized markets where if you have a device, you can actually show up and participate in the market. And so that was what we decided to go after.
With flywheels? With
flywheels. And it turned out that the nature of a flywheel is that it's more expensive than batteries. There's all kinds of energy storage devices, but the flywheel is characterized by having initially high cost, but it lasts forever. And so it's well suited to the utility application.
Because of that high cost of making it in the first place,
right?
It's not as profit, not as you don't get a return on it in the same way.
Well, it's different. I mean, what you have to do is define an application that can use that extended life. Yeah. And that when we studied the marketplace, we realized that something called frequency regulation was the best use for that device.
Oh, interesting.
Regulation is basically the moment-to-moment balancing between generation and load. They're always out of balance a little bit, so you either have to add or subtract all the time. And normally the way that's done is you send a signal to the generator and you say, I need more power, and you adjust something and more power comes out, or you need less, and so forth. But when you do that, it's hard on the equipment. It generates more emissions.
Expensive.
And it makes more fuel consumption, which is more carbon emissions.
Like you have to be standing by in some way.
Well, it's not. It's fairly automated, but it still is not the best solution. I mean, those systems are all designed to run at a constant speed. So we said, okay, let's do that with storage. So the idea was when there's too much power, you store it, and when there's not enough power, you bring it back out of storage and put it back in the grid.
Well, sure.
it was and actually there's an invention, a patent in my name and others that talks about using flywheels to provide frequency regulation. So yeah, it was a new idea at the time.
I remember reading about it a long time ago, and I wondered if you could make a flywheel that would last as long as you needed to have, to have it last. But
these last probably 20 years or more. We said 20 years.
Well, I mean the spinning.
Oh, you mean how much energy? Okay. Right. Yeah. The way a flywheel stores energy is through inertia. So the faster it goes, the more energy you have. So in fact, the energy you store is the function of the speed squared. So if you double speed, you get 4 times the energy. So speed's your friend, but it has to also hold together. So they end up being pretty exotic devices. In fact, the one that is in operation today is about this big in diameter, and the surface speed is about Mach 2.
That's fast.
Right, it is very fast. 16,000 RPM at a diameter about like this.
So how?
And that's how you get a lot of energy.
I mean, I guess you're saying this, as against batteries, there's no real future for it, but I'm just wondering about the technology. So how do you get it up to speed? Use an electric motor, I guess.
Right, yeah, the power goes in and out through, it's either a motor or a generator, depending on how the power electronics interact with it. So you put power in, it comes up to speed, and then you don't do anything, it just sits there and spins along with very low losses, and then when you need to extract power, you drag it back down in speed and you take the power back out. It has a little bit in common with a hybrid vehicle.
Sure.
A hybrid vehicle
gets those replenishing brakes.
Exactly.
Yeah.
So on a hybrid vehicle, rather than taking the inertia of the car and turning it into heat and it's lost, you actually take the inertia of the car and run a generator, and that generates power, and you put it on the onboard battery.
What about friction?
Well, you keep the friction down every way you possibly can, and that turns out to be part of the design of it, the secrets of the design.
Did anybody ever design anything where the flywheel would not touch anything? There would be no axle, essentially?
Well, this is close to that.
Yeah.
It has basically a magnetic lift system.
Oh, is
that
that right?
levitates it. So
Okay.
it's inside a hard vacuum, 10 to the minus 4 torr, not quite outer space, but close. And the whole thing spins around and levitated by a magnetic field. So it's pretty cool stuff.
Yeah, it is.
Yeah.
That's really advanced. Even then, it was not going to be profitable.
Well, if you put it in the right application, especially if you get paid for the capability of the system, then it can be profitable.
Okay, so it's working now.
Yeah, the first facility was built in New York, the New York Independent System Operator, New York ISO. And it's been operating since the summer of 2011. And it's been operating about 98% availability ever since. And to give you an idea of how effective it is compared to generation, that market is about 210 megawatts of capacity for this service. They need it's about a 1% adjustment, if you will, on the grid.
That's huge.
Well, but if you think about it as 1%, then it's not so big compared to the grid itself.
No.
But if it provides, say it's 9% of the capacity, but it provides about 25 or 30% of the regulation effect. So it's a bargain.
Yeah.
And as time went on, we actually were able to get Federal Energy Regulatory Commission, which is something that happens on the mainland, doesn't affect Hawaii. They agreed with that and actually passed an order that said these grid operators have to pay for that benefit. So that raised the price in the marketplace.
So what does that do?
It's about 8 feet tall
Oh,
and
okay.
about a meter in diameter.
Oh, that's the wheel.
Just the wheel
is
itself,
the
right,
thing.
exactly.
Okay, and made of steel?
Actually, carbon fiber. It turns out that if
Doesn't
you do,
have to be heavy.
You'd think, well, I'd make it out of lead, right? That's the most inertia. But then when you get up to very low speed, it starts to come apart because it can't handle the stress. So the stresses are very, very high. So what you have to do is look at the ratio. It turns out to be the ratio of speed to density.
So this is dense carbon fiber.
Well, I say strength to density ratio. So
Okay.
carbon fiber is really good at it. It's extremely strong, and it has a fairly low density.
Yeah.
So that turns out to be the best solution for that
Gee,
application.
this is so appealing, you know. I know it costs too much relative to other ways, but it sounds like it's really high tech.
Well, I think it may be a good application for a utility application
Yeah.
because it does last for a long time.
Smoothing out the curve.
Batteries are always going to have some expiration, some number of cycles they can handle before they have to be replaced.
So you're still involved in Beacon? Or?
Not particularly, no. I mean, do a little consulting.
Okay,
on
so
it.
you migrated out of Beacon.
Right.
Are you an engineer, by the way?
I am. I'm a
Okay.
recovering engineer, like you're a
Okay,
recovering
all right,
lawyer.
yes, I think I better be a recovering engineer, actually. Never, these days. So now you migrated, evolved out of Beacon into
Right.
grid storage.
Yes.
And what do you do as a consultant for grid storage?
Well, what Beacon was able to accomplish is develop the technology, and there's a lot of aspects of that apply, whether it's flywheels or batteries, interconnection with the grid, develop the sites, I did the whole process, where do you put it, how do you go through the interconnection process, all those things. Build a factory to manufacture the things, and then went through all the regulatory steps to get it in the market. When we first started, for example, in the New York, the ISO New England, we were located in Massachusetts, you couldn't do it. You could not provide that service with energy storage. There was some book someplace that said in order to provide regulation, you had to be a generator. So, and that repeated itself thousands of places and all over the country. So we had to go about all the work of figuring out how those rules are written and how they can be changed. And so you had to get a lot of people on your side and realizing this is a better answer. And so we spent a lot of time doing that. We spent a lot of time with the public utility commissioners all around the Northeast, around the rest of the country, with the grid operators. And the other thing about the mainland is that you have, like New York, it's its own control area. So they establish the market and they control all the devices and so forth. And then there's another one in New England that consists of a few states. And there's PJM, which is South Atlantic and parts of the United States. And then there's one out in California. So there's a whole variety of these grid operators. And about half of the United States is divided into what's called organized markets, which was the result of deregulation. And so in those places, you can show up if you've got a good idea and participate in the market, which is the whole idea of deregulation. So in a way, Beacon Power was a poster child for deregulation. And that's one of the reasons I think FERC was so helpful, because that was a FERC idea, Federal Energy Regulatory Commission idea, to deregulate the markets.
So as a person who fits into this space, what do you do?
So right now I'm just doing consulting and providing some of the skills that I learned along the way. whether it's getting markets to be changed and open and available, or figuring out what's the best solution for a given application. The storage it comes in all different shapes and sizes and so
and
forth.
size.
And right, and the needs are also quite varied. So you have to match the need with the right technology.
And actually, you wouldn't want to be on only one side of it, one vantage, right? You'd want to see it from all sides. You want to see the regulatory side, from the utility side, from the customer side. Anyone who touches, the integration of the grid.
Right, and I think that's one of the things that I have. It's not a common set of skills to have all in the same head, so to speak. So I think that's the value I really bring to my clients.
Well, it strikes me that the industry, and you're part of it, has a long way to go.
Yes.
So we
Just
don't
the
have the
beginning.
technology, and it's not synced up.
Mm-hmm.
And people don't know what it is, and they have trouble accepting it and
Exactly.
integrating it.
Right. But it's like solar was maybe 10 years ago. I think we're at the right at the cusp of that technology becoming very commonplace and quite a large industry.
What happens when it becomes commonplace? How do we notice that? How do
Well,
we
I
see
think
it change?
let's just speak about Hawaii. That's going to be the solution to integrate all the variable energy resources. I mean, you have some renewables like geothermal that you can control, or at least are predictable. Then you have others, wind and solar, that are only semi-predictable. I mean, you know that you're not going to get any photovoltaic energy at night, so it's what the potential is during the day. But within that, you have clouds that come and go, and so you have the energy is spiking up and down, and that can have a very negative effect on the grid. So you have to figure out a way of balancing that out.
So if you put all this new, this is like waiting for Godot. If you put all this new technology together and you connect all the parts, the intermittent versus plus the continuous, and the old generating equipment plus the newer, modalities.
Right.
And you connect them with this kind of equipment
That's the
you're
idea.
talking about?
That is the one missing ingredient today that can allow you to smooth out all the bumps, so to speak.
Yeah. So is this the dream, okay, that will be, I'm sure it will happen, will be realized here. Is that a dream that is island by island, or is it distributed by island, or is that a dream that requires or could use or benefit by an undersea cable?
Well, it can certainly be done island by island. I mean, they're much smaller grids than any of the islands today. In fact, I was recently at a summit in Bermuda, and they have the same aspirations that Hawaii does of moving away from fossil energy and renewable energy. But they're a much smaller grid, about 120 megawatts. So would it benefit? I think the question is, what's the return on the benefit? Certainly, on the mainland, there's three basic grid elements. There's Eastern Interconnect, Western Interconnect, and then there's Texas. And they benefit.
Texas.
Well, and it's interesting, they're not subject to FERC any more than Hawaii is.
I see.
And the reason is that FERC has jurisdiction when there's interstate commerce.
Yeah.
So the way they're configured to the other ones is such that they don't have interstate transmission of energy in a way that FERC can, right, and they're very careful to make sure they don't come subject to.
Interesting. I don't expose them to FERC regulation.
Exactly. So it's, anyway, so I think the benefit of the undersea cable would be to get that ability to export and import. If there's a big failure on one island, you can bring in power from the other one and vice versa. You can share the balancing efforts. But it's going to be expensive. And that was actually, right, that was actually one of the things that was in the conference that I'm over here
Sure,
for.
I want to cover that.
Right.
There's one other question on that point is, on a statewide basis, statewide system, which is, in the end, this is what it's all about.
Mm-hmm.
Would some kind of fungible fuel, I guess the whole LNG initiative really assumes that you could take a tank of LNG and move it anywhere you want it, between islands. But what about an alternative fungible fuel such as hydrogen? Hydrogen created, say, from geothermal.
Right. Well, you can do it that way. You can do it straight from electricity. The efficiency of an electrolyzer, it's called, which is what, if you put electricity in and add some water, you can get hydrogen and oxygen out. It electrolyzes the water. And the efficiency of those systems is actually getting to be pretty respectable. So, in fact, they're doing that in Germany now. There's a huge surplus of renewable energy in Germany, many hours of the day and the year. And they're,
Good for them.
Well, they quite often have to curtail it, so they
I've
throw it
heard
away.
that.
They put it in the
We
Capitol.
had,
And
we had your speaker,
you've had curtailment here as well, I know.
well, we had Jeff, Jeff a few days ago sat in this chair. He spoke at your conference. He wrote the paper on Germany.
Oh, Altman? Jeff
Altman,
Yes,
yeah.
right. He started the conference with a long discussion about some of the issues that have occurred in Germany and some of the problems they've had.
What about actual batteries, though? You could suppose I made a barge full of batteries, and I went over to the Big Island. I got to Pune. I mean, if there's a harbor there, maybe. and I wired it up to an energy source, an electrical energy source, and I charged the batteries on the barge, and then I moved the
Transport
barge.
it?
Take 2 or 3 days.
Yep.
I moved the barge to Honolulu. Now I have a barge full of energy.
Well, that's a new idea, I would say. I've not heard of that idea. I mean, that one of the issues is that the batteries are fairly large and heavy and so forth, but you have to do the math on that one. I don't know.
Have to do the math, right?
Right.
So let's talk about EUCI,
Yes.
at which Jeff Altman spoke, and I trust you spoke too.
Right. It's the 4th annual Hawaii Power Summit is what it was about, and had great support from Hawaiian Electric. They were actually a sponsor of the conference, and I worked with I'm not formally part of the EUCI, but I was working with the.
What does that stand for?
I don't remember. It's been around for a long time. I just know it is.
It's about energy.
Right.
Okay.
And their focus is on these various conferences where there's a lot of training involved. In fact, they offer continuing education credit for some professions, engineers, lawyers, and so forth. So that's really has been their historic focus is on take a topic, usually with some technical aspect to it, and then figure out a way of doing a conference and getting people interested in it.
Okay. I want to go.
So I was
through
involved in 2 panels. One was on high penetration photovoltaics, which is clearly a big issue here in Hawaii in terms of not going beyond a certain limit. And then the second one was on just the integration of renewable energy.
in general.
Right.
Let's take a minute. That's Bill Capp, Grid Storage. He's a consultant, and it's all about grid storage. It really is all about grid storage. Here in Hawaii, the state of clean energy. I'm going to call in the show Storage at the Center. I'm Jay Fidell. We're going to take a short break. We'll be right back.
Aloha, I'm Hunter Hevelin, host of Sustainable Hawaii here at ThinkTech Hawaii. You can tune in every week on Thursday at 2 p.m. to see interviews with sustainability professionals from around the state and even further abroad, learning about activities with water management, food security, waste management, and a whole host of other fascinating opportunities to get engaged with making a greener island. So if you're interested in making the transition from consuming individuals to communities of producers, check us out every Thursday. Aloha.
Okay, we're back. We're live. I'm Jay Fidell here on ThinkTech in Hawaii, the state of clean energy, talking about storage at the center with Bill Capp of Grid Storage, who participated in the 2-day EUCI conference in Waikiki, all about energy, namely 2 issues. How do you best integrate into a grid, and how do you best renewables into a grid, and how do you best integrate in general, in energy? I mean, really very important issues technologically. So the first day was a workshop, and the second day was.
Well, it's actually 3 days. The first day I did a workshop on energy storage called Energy
Okay, you
Storage
with Jeff
101 and
Altman
201.
Oh, you with
No,
Marco? Marco
no,
Mango's
he was
there.
on a different panel.
Okay.
I did this
All
with
my
a couple
friends
other
were
people.
there,
This is with a couple other people in the storage industry.
Okay.
One of them in thermal storage, which is an interesting, different way of approaching energy storage. So that was the first day, and that was
What kind of storage is that?
thermal
Oh,
energy
thermal.
storage.
Oh.
So it turns out you can control a fleet of water heaters in a way that's useful in terms of managing the grid.
You have to get them to be 90,000 degrees Fahrenheit or something.
Well, you do go above the temperature to be comfortable with, but they have a way of accommodating that through a mixing valve.
Okay.
So you overheat the water from, you don't it can be above scalding, but then when you bring it out, you can take it through a mixing valve, such as whatever temperature you want it to be, so it's comfortable.
After a while, we're going to develop a steam engine. I'm only kidding. Anyway, so now that was the
That was
first
the workshop.
Day. That
So
was the
then
workshop.
Then the panel itself, I mean, the conference itself was two days of panels, and
Okay.
Jeff was on the first
Yeah.
panel on the first day.
Yeah, and Marco was on the second day.
He was the second day, and he was in the on the panel just before the one I had on integration of renewable energy.
Okay, what are the takeaways that we should mention here?
Well, a variety. I think without question, everyone agreed that energy storage is going to be part of the future and part of the solution to integrating renewable energy. That no one took issue with that. The question is, you have basically the thing that's providing a lot of that variation, or storage, if you will, is the fossil fuel fleet that you have today. And there's a lot of talk about turning that into LNG, but in general, the goal is to move away from fossil fuels. So at what ratio or what point can you start moving more storage in to replace the fossil fuel generation, I think is the key question. And it's a little bit unknown right now. And fortunately, the price of energy storage is going down pretty quickly. In fact, I had someone on my panel from Tesla, the electric
They're working on
car
a battery,
company.
yeah.
They are working on a stationary battery, very much so. In fact, they're starting to bring them out right now. In fact, this was really the second place where Tesla, to my knowledge, had come out and started talking about it. The first one was at the Energy Storage North America conference in San Jose about a month ago.
So what is the new technology they're playing with?
Well, it's the same batteries that they use on their vehicles. There's a bunch of small Panasonic cylindrical batteries.
But bigger? More
No,
of them?
No, it's the same basic dimensions. The battery in that vehicle is like 85 kilowatt hours, so it's a large battery by itself. And so the first place it's going to be introduced is on residential systems. And they have a 6 to 8 kilowatt hour residential system that's designed to be bolted right up next to the photovoltaic inverter. And that enables the ability of people to become independent if they want to from the utility. I mean, in theory, you could have a non-export facility or even an off-grid facility.
Is on the market yet?
It will be coming out soon. It's available on the mainland, but what he said was they're coming out with a second generation, and he said it will be very inexpensive, whatever that means. He didn't elaborate.
These guys are so smart. They'll do it, too.
Well, I'm sure you know that they have a relationship with Solar City. So that
Right,
the
right.
Tesla technology will be implemented in Solar City on the residential side.
Ready-made market.
But they also have developed a utility scale version too, and this starts to look like a big transformer. And it has.
How big is big?
It's a 2-hour system, and I think it's a 2 megawatt system. So it's a pretty substantial asset. From
So
the grid
if I wanted to do, say, 200 megawatts, I get 100 of these
Right.
things and strap it together.
Exactly. And it's designed to do just that. In fact, if you visit their facility in Fremont, California, you'll see some of these devices right outside the factory, because they're doing some of the peak shaving, and they're getting to know their own equipment that way.
Sure, and testing and all that.
Right.
So lithium, is it lithium?
Lithium-ion, yep.
Gee, buy lithium.
Yeah, I mean, what they're doing is they're building what they call the Gigafactory. I don't know if you saw that. It was very much in the news for a while. Yeah, in terms of which state was going to get the go-ahead, and they picked Nevada.
For Tesla.
Right, they
Yeah.
picked Nevada, and my sense is about 25% of that capacity will be devoted to the stationary grid application. So it'll be a substantial producer of that kind of equipment.
Wow, this is really a step ahead because, as you said, this is, central, as I call it, storage at the center.
Right, exactly.
It's central to the whole renewable effort, and wow. If they came up with a relatively cheap, I don't know if they talked about prices, a relatively cheap battery for residential use, that would change everything for all those people who didn't want to spend a lot of money, for example. If they could spend a fraction of that for a battery that hangs outside the inverter there.
Well, I think there's a lot going on in that regard.
Yeah.
And the one way of thinking about it is it's a lot easier for the utility to integrate if you don't have this sudden discharge going on and off the distribution circuit. That's really the essence of the problem.
Yeah.
You have the way the distribution circuit was designed, it starts with high voltage at the substation, and then the voltage goes out across the circuit, and generally it's going down in voltage to the end of the circuit. Each home and load is bringing that voltage down a little bit. Yeah. And Hawaiian Electric or any utility has to stay within certain set limits. Let's say it's plus or minus 5% of the nominal. So if they don't get that right, they can have either have the voltage too low or too high, in which case they're subject to probably fines and certainly bad behavior on the part of the utility.
And it's risk. It's
And
also
it's
risk
for
for the
everybody.
system.
Right.
And maybe there's danger also, I don't know.
Probably not within limits, but so in order to, so they have, that's the way the circuits have all been designed. So now you say halfway down this feeder circuit, you have an injection of power called a photovoltaic inverter. Now the voltage comes back up again, and it becomes very unpredictable than what can happen across that circuit. And there are solutions for that, and we talked about that in the workshop, on the panel about high penetration.
How to solve that problem.
Right. Some of them relate just to the voltage issue, and some relate to other issues. But if you were to put storage at each home, then you could just say, I'm not going to have that problem. I'm not going to export suddenly or unpredictably. I can export in a certain time or at a certain rate, and Hawaiian Electric can control that in a way that's much, much easier to integrate.
Well,
So it could enable getting past the limits that exist now.
Yeah, solve the interconnect problem right
Exactly.
away, yeah.
Right.
So, if you wanted to start with low voltage, wait, you want to start with, low voltage at the house.
Right.
Why wouldn't you just put the battery between the cells and the inverter? Never change it to alternating current. What about that?
Well, I'm not sure. I mean, the loads in the house are all going to run on alternating current, right?
Yeah, but I mean, if you wanted to start with a low voltage, how do you achieve that?
Well, the batteries themselves are.
They're low voltage.
Each as a cell, they're maybe 2
Okay.
volts or so. So you stack them up in series
Yeah.
and in what's called a battery string,
Yeah.
typically to 600 to 800 volts. And
And-
that's what goes into the inverter, and then that's what feeds back into
Okay,
the
right,
grid.
and that doesn't matter whether it's alternating or direct.
Well, the inverter's job is to go from
Direct
direct
to
current to
alternating.
alternating current, and also synchronize with the grid. That's very important because the voltage on the grid is, always going down. So it has to get on
The
board.
inverter does that.
The inverter keeps track of what's going on the grid and
So
matches it.
What's between the battery and the grid then?
The inverter. So the batteries are DC, and then the inverter goes from DC to
Got it.
AC and
Okay.
connects directly to the grid.
That's what I was thinking, yeah, okay. So does the utility need any extra equipment other than this battery and the inverter?
Well, the utility has done a good job of integrating a lot of these variable resources to this point, and then it got to the point where it just wasn't manageable, and that's when they said, we've got to slow this down.
Right, this would help.
This would absolutely help. In fact, if they came out with some statements at the end of October talking about what they're going to do to rectify this queue, one of them was getting rid of, some of the inverters have another problem, it's called transient overvoltage, that if you disconnect, you can suddenly get a spike from the inverter, an unexpected spike that either damage the equipment in the house or in the neighbor's house. So the first thing they did was to make sure that the inverters that get installed from this point on had been tested to not have that attribute, so to speak, or that defect. Then the other thing that they looked at was being able to bring all these other resources online as quickly as possible. But if they knew for sure that you wouldn't have this unexpected discharge or feedback to the grid, then they could do that much faster.
Okay, well, so is the notion that the Tesla type of battery would be within the financial ability of the average homeowner? I mean, what do you think it's going to?
Well, I can tell you what the rumor is. I mean, Tesla is.
We like rumors.
Yeah. They have not said what it'll be, but the rumors would tell me it's going to be under $4,000 for a system that would be 8 kilowatt hours.
See, now that's way less than a system that was developed here, which you may know about. It's the M-Power system, Joe Saturnia, which was more for an
Well,
average
if you look
house.
at the average price of lithium-ion batteries, and that's the most commonly used today for grid connection,
Yeah.
they've gone from about $1,500 a kilowatt hour as a unit of energy down to maybe 500. It's got to be a common number.
So that's why it's cheaper.
Right, and Tesla is if they do that, they'll be leading that down that curve, so to speak.
How do you make it safe? Because there's a lot of energy in there.
Well, I think the key thing is what's called the battery management system. It's another layer of electronics and programming. They keep track of what's going on with every single cell. I mean, there may be hundreds of cells in this device, and they have to keep track of each one of those because the batteries by themselves tend to, one of these cells want to do all the work naturally, and so they have to make sure that everybody shares the work.
If you share it, then one cell doesn't overheat.
Exactly.
So what happened in the extreme fire in Kahuku a couple of years ago?
That's not really known for sure. As I understand it, it's still subject to litigation, but there was discussion about the electrolytic capacitors and the power electronics, the inverter. But to my knowledge, that really hasn't been resolved yet.
Okay, so that was one of
And that, by the way, was
upshot-
a different chemistry. That was a lead-acid battery.
Oh, that's right. Yeah.
It wasn't lithium-ion.
You know, I went out to see the Verizon switch, which is another way of saying all their electronics. And of course, they're broadcasting through all these towers, and they have a switch. It's a building, and in the building is lots of electronics. And they have a backup system, and the backup system is lead
Lead-acid
acid.
batteries, right.
Yeah.
Probably
Why
flooded.
isn't it lithium?
Well, it might be in the future, but today, if, let's say that lithium-ion batteries are getting down to $500 a kilowatt hour, lead acid is about 150. So
There
it's
you
still
go.
way,
It's just
way
cost.
less.
Yeah.
And the difference is the cycle life.
Lead
And-
acid
and
takes a longer
It
life.
doesn't live as long. It has a shorter number of cycles.
I mean, they were open, and you walked around with some distilled water,
Right.
poured it into the
That's a
battery.
flooded
It was
right. Those are very common for those kinds of substations, right?
that was their system.
Mhm.
Anyway, so what about the other technology that was discussed at the
The
EUIC?
thermal energy storage?
Yeah.
That one?
Yeah.
Well, there are other forms of storage we talked about as well. I mean, even pumped hydro, and I understand there's a possibility of doing that on Hawai. I'm not sure. One of the islands is actually looking at that. They have apparently a reservoir that they can use. And that pumped hydro is basically, and that's the most common form of energy storage in the world.
And it is actually in use today.
Oh, yeah. A lot of it was built back in the 60s when the nuclear fleet was built, because they knew that they'd need to adjust the amount of power by storing it and releasing it, because those fleets don't move up and down very easily.
Am I right to say we don't have any of it in Hawaii?
Not to my knowledge. I'm not sure of that, but not to my knowledge.
Yeah, I haven't heard. Let me
But
take a short break, Bill. That's Bill Capp, consulting on grid storage here in Hawaii, the state of clean energy. We're talking about storage at the center, and specifically we're learning about what happened at the EUCI conference in Waikiki just a day ago, a couple of days ago.
Right.
We'll be right back after this short break.
Aloha, I'm Keli'i Akina, president of the Grassroot Institute. One of the things I love being, however, is the host of the weekly program on ThinkTech Hawaii called Ehana Kako, which means let's work together. I get to interview movers and shakers in our town and across the world so that you and I together can learn and to grow. Please join me every Monday from 2 to 3 p.m. or watch us on the recording, www.thinktechhawaii.com. Aloha and ehana kako. Let's work together.
Okay, we're back. We're live. We're here with Bill Capp, Grid Storage. He's a consultant here in the state of clean energy about storage. Storage is at the center. That's our show. And we're talking about, of course, batteries, but then we're talking about pumped hydro, which always interested me.
Right.
You want to talk more about that?
Sure.
And maybe also about, what was the other one? Thermal.
Thermal
you
energy storage,
mentioned,
right.
yeah.
Well, the pumped hydro is certainly the most common, and a lot of it was built in the past. There's a little bit being built today. The limitation is usually around permitting, because there's all kinds of stakeholders that get involved if you start, creating a lake someplace or changing the function of an existing reservoir. And so it's not uncommon for those projects to take 10 years, and that's a long time if you're trying to solve a problem that's coming quickly.
Well, in 10 years, there'll be another technology, so it'll be overtaken.
Well, pumped hydro has
somehow.
been around, probably 100 years, so it's the oldest and certainly the most common, but it does have this limitation of taking a long
Hawaii
time.
has a different view of land,
Well, and that's not uncommon.
Yeah.
A lot of people feel that way. But if you can do it, that's certainly the best solution, because you can store a lot of energy and it's very inexpensive per unit of energy storage, and no particular limitation on cycle life.
What do you need to do? You need to have a reservoir. You need
Right.
to line the reservoir. It can be earthen or what?
Well, the key thing is you have to have two reservoirs that are different altitudes, different elevations. And what you do to store energy is you take water from the lower one and pump it up. Energy goes in, run the pump it up to the higher reservoir level, and it sits there. Now it's charged, ready to go. So then if you want to discharge it, then you reverse the flow through the penstock, and what had been a pump turns into a generator.
Oh, same equipment.
It could be, or it could be separate.
Okay.
They're done both ways. And then so you get the water flowing through and you generate power just like when you run a river hydro.
Okay.
So it's pretty simple conceptually.
Yeah, but you have to be, so can it be earth? Must it be concrete?
I think most of them are probably natural reservoirs, just
Natural
first line, but
reservoirs.
they've been done lots of different ways.
And how, before it gets, to the right economy of scale, how big does it have to be?
Most of them are quite large. Ones I can think of are 100 megawatts or more.
Which is the size of a real lake.
Right. Yeah, they're quite
Okay.
substantial.
And the difference in altitude, does it have to be very great, or can it be just, sort of
I think about
adjoining?
500 feet is probably about
So you have to have a
typical for
mountain there somewhere.
Yeah, something that looks pretty substantial.
Have any sites been looked at in Hawaii yet?
Yes. In fact, I believe there's one that's being evaluated now, but I can't remember which island. I think it's Kauai, but I'm not sure.
Yeah, okay. Well, I'd like to see that happen. I
Mhm.
mean, if we're talking about distributed energy,
Mhm.
that really works for island by island method of distribution.
Right, and you can store, a lot of them are designed to store 2 or 3 or 4 days of energy, so it's quite a substantial amount of energy.
Yeah, and it doesn't have to be covered, right? It's just a hole in the ground.
Right. Yeah. Although people are looking at, there's designs in place to do that kind of thing, actually have one in an underground reservoir, rather than having it from high altitude, put it down a reservoir down below.
Sure.
So,
If you wouldn't use drinking water, just any water would be fine. Right. And the only real problem is the deterioration of the actual reservoir over time. Who
well, I
knows
think
why?
there's a certain amount of evaporation that occurs, so you do have losses of water, and that could be a problem if you have limitations on the amount of water available. Although some have been done with seawater, where they actually have a reservoir higher up, and then they pump, the sea is the lower reservoir, so they pump the seawater up and then they bring it back down
Save
again.
the cost of another second reservoir.
Right, exactly.
But of course, then you have corrosion issues. And
Right.
I was going to say that the one factor that may shorten the life of, or cost more, is the equipment itself, because it's mechanical, and it's going to deteriorate, require maintenance.
Well, it does require maintenance, but if you look at it based on the amount of energy that goes through it, it's still the most economical.
Yeah. Okay. All right. Thermal.
Thermal energy storage is one that has been used in France. EDF, the grid operator there, as I understand it, actually mandates homes to have these systems in place and be controllable by the grid. And basically, they turn them on and off, which is one level of what's called demand response, where the grid operator can say, I have a problem, I need more power, so I'm going to turn off some loads here and there. Or you could say, I need less power, so I'm going to turn loads on to a higher level. That's the essence of demand response. What's happening is you're combining digital electronics with an old idea, which is a water heater. And so there was a company there called Steffes that talked about their product line.
How do you spell?
Steffes. They're based in North Dakota, I think. And what they've done is to have a well-insulated water heater, and they actually run the temperature up to a higher level. So you can charge it up at night and not have to turn it on during the day, even though you get all the hot water you need. But the other thing that allows you to do is to put in more energy than you would normally need, and so that becomes your energy storage. So you have the ability of adding maybe 15 kilowatt hours of energy in the form of heat into those systems. And so if you want to charge at night, say you've got more wind at night than you need, then you could heat up all these water heaters, and that would be the way you'd store the energy. It doesn't turn back into electricity again, but you use it in a way that it looks like a controllable load.
Well, here's the thing. I remember all this aggravation about curtailment of wind in Maui and all that.
Right.
And everybody was all hoo-hoo about that. You're throwing away the product of our investment and all that.
That's true.
And I had this vision of the wires into the ground, essentially grounding this valuable commodity, electricity, which runs our society. We're virtually throwing it away.
You are throwing it away, right?
So with the storage devices you're talking about, these modalities, seems to me that we don't have to throw anything away anymore.
That's exactly right.
There's always going to be a place for it.
Right.
Keep it.
That's
use
the
it.
idea. It's all about how much storage do you need, and where do you put it, and that's what needs to be sorted out.
Okay. More takeaways from the program?
Well, one of the discussions that was interesting to me was LNG. Both Hawaii and Bermuda are looking at the idea of using LNG as a bridge fuel. And it was a very interesting panel, very well done. You had people on both sides of the issue. And the person who was less interested in bringing LNG had pictures of probably 20 different bridges. And he finished with the one that was a bridge that went into this fog bank. And you couldn't see where it was going. It was like unknown. And he was trying to make the argument that there's so much volatility in pricing and so forth. It's really hard to sit here today and make a 10 or 20-year decision about the price of fuel, which is probably true. So I think that was, but it was typical of the whole conference to have this kind of lively debates back and forth. The guy from Germany talking about the problems that came around associated with the high renewable penetration. Yep.
Yeah. So did anybody talk about exactly how it would be done mechanically? Because I don't know if they figured that out, LNG.
Oh, well, they talked about two things. One was bringing it in containers, and the other one is to liquefy it and then, those are being built around the United States now with a surplus of fracked gas. You're building LNG platforms so you can export, put it on a ship, and take it wherever you want to take it. And so that's the other one. That's less expensive to bring it in bulk, so to speak. And that was the other approach. That costs a lot more money and takes longer to implement.
So in the deal that's going down with NextEra and Hawaiian Electric.
Yeah, that happened right in the middle of the conference. It got a lot of attention.
You guys, everybody
probably
buzzing in the back room. Yeah.
Right. I mean, suddenly everybody had their phones out. There were probably 40 or 50 people there from Hawaiian Electric. So.
Where does all this fit? You know, I'm sure that, as you mentioned, that you know, storage is going to play an important role in dealing with the interconnectivity problem, and dealing with the build out of the grid,
right.
You know, with new technology and new capability, and maybe new products we can't even think of right now. Who knows what?
You've got to assume that they'll keep coming. They always have. Right?
Yeah. The thing about electricity, as always from the days of Edison, is you can't imagine what it can do, and you can dream of it like science fiction, and it comes true. All of it and more.
Right.
And
Absolutely.
This is another time, another disruptive time. Storage.
I think it is. I think the storage industry is going to be taking off. It'll be probably 10 times its current size, 100 times its current size before you know it.
Yeah. So where does this all play in the? If you have any ideas about it, in the deal with NextEra? They are very technology aware. They've done a lot of technological things.
Well, to my knowledge, they are the largest owner of wind and solar assets in the country, maybe the world. So they're very experienced with what Hawaii is trying to do. And I'm just going to speculate here. I think that they view this as a laboratory to go to high renewables penetration, which is going to be happening around the world. It already is in Germany, and it certainly will be on the mainland. California's not far behind Hawaii. So I think they view this as a way of proving the technology and getting good at it and figuring out who the winners and losers are in that space.
Raises all boats, doesn't it?
Well, I think they'll do well, and I think some of the people I talked to at Hawaiian Electric were enthusiastic about having more people to work with because they have a lot of technical expertise there.
Yeah, because actually, transforming a grid isn't easy.
No.
Especially when the technology is changing all the time.
Well, and it's like changing the tire while you're driving down the road.
Exactly.
You can't stop and say, well, we're just going to turn the grid off for 6 months. It just doesn't work that way. So that's the real challenge.
So what did you talk about? And this is a bifurcated question, but what did you talk about? And how will you participate in the new world coming soon with NextEra?
What I talk about on the panel, you mean on renewable energy, or?
Yeah.
Well, I was more of a moderator in that case. I was really pleased to get someone there from Tesla, and we had Colton Ching from Hawaiian Electric, who's certainly one of the really skilled people there, and someone from S&C Electric and from Steffes. So we had a good group of people there to talk about all dimensions of it, and I was pleased to have them get together and went through a series of questions and so forth. I think it was informative for the group. I was a little bit more engaged in the photovoltaic panel in terms of, I did sort of a primer on what the issues were and that kind of thing. But I'm very interested in being involved in Hawaii in some way because I, like so many others, think this will be the future of renewable energy. Commissioner Akiba likes to talk about postcards from the future. And I think that's the idea is that we're going to be there before, Hawaii's going to be there before a lot of other people are. And given my enthusiasm for the whole subject of integration of renewables and the work that was done at Beacon, I think I'm in a good position to help with that. So I'm here looking for that opportunity to see if there's some way I can do that on a permanent basis.
Probably you have to come back on the show. We have miles to go.
Well, I'll be very pleased to come back the next time I'm here.
You know what they say, Bill? The future isn't what it used to be.
That's true.
That's Bill Capp, grid storage in Hawaii, the state of clean energy. Storage at the center has been our discussion, and we'll do it again. I'm Jay Fidell. Thanks so much. Thank you, Bill.
Thank you, Jay. Appreciate it.